Today's notes are all about rates of change, the rate at which a function changes. So notebooks out, make sure we're taking good notes here. The rate at which a function changes for a line is called the slope. We're talking all about slope, review lesson today. The rate at which a function changes is slope. So slope, rate of change, we want to think through, okay, I've got 3 lines here. If we're talking about the rate at which these functions change, we're looking at how quickly they're going up as we read the graph from left to right. So we are asked to put the lines in order from the smallest to the largest rate of change, or smallest to largest slope. So this blue line is pretty clearly growing the slowest as I read it from left to right. And then this black line is steeper. That would be the one with the second slope, and the one with the largest slope as I go from left to right. This is the steepest line. This function is changing the most. So the rate at which a function changes, this one is growing a little bit, this one's growing a little more, this one's growing significantly more. So the slope, what we're looking at, we want to start understanding that slope is a rate of change. Our slope, our rate of change, could be positive. As we just looked at the last ones, all 3 of those lines, as well as this line right here, as I go from left to right, this function is increasing in value. It's getting bigger. We could have slopes that are negative. We have functions that are decreasing, going down as I read them from left to right. It's possible that the function is neither increasing nor decreasing. We say that the slope is 0 in that case if we have a horizontal line. Or it's possible as I go from left to right, my function is getting infinitely big. It's not going right at all. It's just going straight up and down, in which case we say the rate of change or the slope is undefined. Vertical lines have a slope that is undefined. Slope is always finding how much the y value changes for each one change in x. Each time we change the x value by 1, the amount that the y value goes up or down is the slope. How much does y change for each change in x? There's several different ways that we have learned to find slope. If we're given a graph, a lot of times we think through rise over run. Slope is rise over run. We take how much the graph goes up and divide by how much the graph goes side to side. How much the graph goes up, that's how much the y value changes overall. How much the graph goes side to side is how much the x value changes overall. And if we divide those things, so like maybe the y value changes by 8 and the x value changes by 4, what we're getting is we're getting a slope of 2 because that reduces to 2 over 1. So each time the x value changes by 1, the y value changes by 2. How much y changes each one change in x? Rise, how much it goes up and down, that's our change in y. Run, how much it goes side to side is change in x. So that's another way we can kind of think through slope, think through rate of change. Take the overall change in y and divide by the overall change in x. And then we had the formula that has been introduced to you, y2 minus y1. Notice if I subtract y values, that's giving me a change in y. If I subtract x values, that gives you a change in x. So any of these three ways are good ways to think through finding slope. When we use each of these ways, we use rise over run a lot of times if we are given a graph. A lot of times we'll think through change in y over change in x, the overall change in y divided by the overall change in x. If we're given overall changes. And then y2 minus y1 over x2 minus x1. All of these, we're doing the same thing, but a lot of times we'll want to use this when we're given 2 points. We're given 2 ordered pairs. We are going to work through some examples here. The examples come from a packet, which is over by the turn-in tray. So you don't need to write these problems down. Go distribute the packets and then work through them on the packet itself. So we're going to do a few of them together. You'll have time to complete the rest of them. Question number 1 says the average adult breathes in about 37 liters of air every 5 minutes. What is the rate of change of volume of air? So notice here we're not given 2 different points where I'm going to do y2 minus y1 over x2 minus x1. We're not given a graph where I can count what the rise is and what the run is. We're just given an overall change in volume of air. We know we have 37 liters, and those 37 liters, we breathe those in over 5 minutes. 37 over 5. Let's go ahead. We can use a calculator here to divide it out. I understand you can divide it and get a decimal without the calculator, but let's do it with. 37 over 5 gives me 7.4. 7.4 is our rate of change. That's our slope. We should include units here. We say that there are 7.4 liters breathed in per minute. Notice liters per divided by minutes. So each minute, we are breathing in 7.4 liters of air. Skipping ahead to number 5. Number 5 gives us a graph. Notice on the x-axis, we have the altitude measured in meters. On the y-axis, we're given temperature measured in degrees Celsius. We are given a line. We're told the 2 endpoints of that line. Part A asks us to calculate the slope of the graph. Find the slope of the graph. Usually when we're given a graph, we count rise over run. The problem is this point's not right on this corner, and that's nowhere close to a corner. We can't really count squares. That's tough to do here. Let's go ahead and use the 2 points, 225 and 2213. And let's use that formula because we know 2 points. We're going to use y2 minus y1 over x2 minus x1. I'm going to label my points. This is the x value of the first point and the y value of the first point. This is the x value of point 2 and the y value of point 2. So we've got 13 minus 25. y2 is 13, y1 is 25, x2 is 2200, x1 is 200. I've got negative 12 over 2000. If it wants it as a fraction, we should reduce it. We can divide by 2, negative 6 over 1,000, and then divide by 2 again. Negative 3 over 500 is a great answer. Our units, notice it's a change in y over a change in x. These two things here, those are temperatures, right? 25 and 13. So degrees Celsius over change in x meters. And again, if it asked for a decimal, we could get it. 3 divided by 5,000 is 500, right? Negative 0.006. We have a negative slope. This line pretty clearly has a negative slope. Part B, interpret the slope as a rate of change. Interpret the slope. Tell me what that slope means. Slope, remember, is the change in y for each one change in x. So in each increase of 1 meter in altitude, so each time I change x by 1, that's where we should start. Each one change in x has a negative slope, so has a decrease of 0.006 degrees Celsius. The temperature decreases by 0.006 degrees Celsius each 1 meter gained in altitude. Each time I increase x by 1, the y value goes down by 0.006. Let's take a look at a couple more. Next one we're going to do is the very next problem, number 6. It says the price of a loaf of bread increased from $1.45 in 2003 to $1.78 in 2006. We are asked for the average price increase per year. How much does the price increase per year? Each year, that's a slope, that's a rate of change. We want to know how quickly is this price going up or how quickly is it going down? So we are looking for the price increase per year. So I need the change in years on the bottom. And I need the overall change in price on the top. If I can get the overall price increase and divide by the overall change in time, that will give us the average price increase per year. So the change in price, it went from $1.45 to $1.78. It went up by what, 33 cents? And the number of years, it started at 2003 and now it's 2006. We had 3 years that went by. It increases by 11 cents per year. $0.11 increase in price per year. You could also identify 2 points here. If we are identifying 2 points, that if we have time in the problem, time is always x. So time, which in this case is the year, if there's time in the problem, time is x. We would say that the price of the loaf of bread depends on what year it is. So years are my independent variable x, and cost is the dependent variable y. So if time is x, I could list out the year 2003 matches up with $1.45. 2006 matches up with the price of $1.78. And then we could use y2 minus y1 over x2 minus x1. That'd be a good way to do it as well. Last one we're doing together here. Question number 7. Nope, not number 7. We're skipping 7 for now. Number 8 gives us a table. It shows the minimum volume of water needed to fight a typical fire in rooms of various size. We're not going to do part C. We're just doing A and B here. So we have a floor area of 25 square meters. We need at least 39 liters of water in order to fight that fire. It asks us to graph the data. Notice the amount of water we need depends upon the floor size. This is my independent variable, is floor area measured in square meters. I'm going to label the x-axis as such. Floor area measured in square meters. My vertical axis is minimum volume of water. Measured in liters. Looks like my floor area is changing by 25 each time. It needs to be no bigger than 100. I'm going to count by 25s. 25, 50, 75, 100, 125, 150. This changes by 39 each time. Let's count by, we need to get up to 120 at least. I'm going to count by 20s. 20, 40, 60, 80, 100, 120. And we're past that 120 we needed. And then we just plot these points, 25, 39. 25, 39 should be pretty close to 40 there. 50, 78. 75, 117. And we can draw the line in that connects those points. Calculate the rate of change. Rate of change is slope. Slope's hard to tell on this graph here. It may or may not go exactly through 0, 0. I know this point, but based on the graph, is it 40? Is it 38? Obviously, we know it's up here. So let's use the table to find the slope, find the rate of change. If we have a table, what we're going to do is we're going to choose 2 of the points. I'm just going to use this point and this point. Those are the smallest one, and we're going to find the slope between those 2 points. You can list them out as ordered pairs, or remember, we do have an ordered pair here, 25, 39, 50, 78. So it's always change in y, y2 minus y1. We're finding the overall change in water and dividing by the overall change in floor area, 50 minus 25. Notice that gives me 39 over 25, which is a fine slope written like that. Again, if it's asking you to write it as a decimal, we can use the calculator to do that. 1.56. This is telling us that the volume increases by 1.56 liters each square meter of flooring. Each square meter of flooring needs a minimum of 1.56 liters of water to put out the fire. Had we chosen 2 different points, had we chosen this point and this point, 117 minus 78 divided by 75 minus 50, also 39 over 25. Maybe you choose the first point and the last point, 117 minus 39 over 75 minus 25. This is 78 over 50, which I can then divide them both by 2, also 39 over 25. So any of the points you choose, we get the same slope. There is our rate of change, 1.56 liters of water for each square meter of floor area. Those are all the ones we're doing together. Check Google Classroom on where to go from here.